Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. For us to create the smallest number, we need to pick the smallest digits at the start of the number. So the smallest digit is 3, then the next smallest digit is 4, next smallest digit is 5, then the next smallest digit is 8. But it wants it to be an odd number, and this is an even number. So we have to move that 8 forward one and have that 5 at the end. So the smallest odd number is 3,485. The key says that a circle represents 8 DVDs, but if we cut this into 4, each quarter represents 2. So we're looking to see how many DVDs were sold on Wednesday. So that would be 8 for this one, and then it's 2 per quarter. So 8 plus 2 is 10, plus 2 is 12, plus 2 is 14. So the answer is going to be 14. This question's all about like terms. So what we can do is we can add this 10u with this 11u to make 21u. We can also add this 6v with this plus 4v to make 10v. We can also add this 10w to this minus 6w. So 10 take away 6 is 4w, so plus 4w. But we can't add a u term to a v term to a w term. So we have to just leave them be. So our answer is 21u plus 10v plus 4w. But we can multiply them, we just can't add or subtract them. A comparative bar chart is where you have two bars next to each other meaning different things. So it's probably easier just to start drawing it, and then we can talk about it as we go along. So we've got males here at 12, and so what we want to do is a bar that is 12 high, and these are going up in 2s, so it will be up here. There we go. And then right next to it we're going to do females, which is 14. And so what we're going to do is we're going to make this go up to 14. And there we go. Now, we need to be able to tell these apart, so what I'm going to do is just shade in the females. And we should do a little key. And we say that if they're not shaded, it's males. And if they're shaded, that is females. Okay, let's carry on with the bar chart. So it's 14 and 6. So notice I've got gaps between the pairs. So we've got 14 and 6, which will be down here. And again, we're just going to shade in the females. And then finally, we've got 8 and 16. So 8 would be here. Then 16 be up here, and finally obviously we're going to shade in the females. The first thing we need to work out is the fraction that Sarah will receive. Well, if Jane receives 9 over 10, then that just leaves how much of the numerator to match the denominator. So 9 plus 1 is 10, so it leaves 1/10 left for Sarah to have. And the reason that works is that the total amount needs to add up to 1, and 9 over 10 plus 1 over 10 is 10 over 10, which is just 1. So next we need to find out what 1/10 of 60 is. So we know that we divide by the bottom and times by the top. So 60 divided by 10 is 6, and then 6 times 1 is just still 6. So our answer will be £6. I'm going to start by writing out all the outcomes. So I'm going to start with trout. So for trout, as a main, I could have had biscuits for dessert. Trout as a main, I could have had cheesecake for dessert. Trout as a main, I could have pancakes as a dessert. Then I'm going to move on to a curry for main. So for curry for main, I could have had biscuits, could have had cheesecake, and I could have had pancakes. Now, to work out the probability, it's the amount of successful outcomes over the total amount of outcomes. So successful for this is a curry and pancakes. So curry and pancakes is a successful outcome, so it's just 1. The total amount are 1, 2, 3, 4, 5, 6. So the chance of me picking at random a curry and pancakes is 1 over 6. So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now, this might surprise some people because they will probably think it's a ratio of 4 to 1, but we can show here that it's a ratio of 3 to 1. A side elevation is the view you'd get if you were standing at the side of a shape. So I'm standing here, and it's the view I'll get. Well, it would be this trapezium here. And to know which side is the side and which one's the front, well, the front is always going to be labelled. They do normally label the sides as well for you. So we're going to draw this trapezium. So the top bit is 3, then it's 6, then it's 8. So I'm just going to start off with the bottom, actually. That might be easier. And draw the 8 across. 1, 2, 3, 4, 5, 6, 7, 8. Then I'm going to do the 6 up. 1, 2, 3, 4, 5, 6. Looks like I left just enough room. Then I'm going to do the 3 across. 1, 2, 3. And then all I need to do is just join up the start and the finish to complete the trapezium. So trying to describe the single transformation, it kind of looks like it could be a rotation, and it would be a rotation of 180 degrees. But if it was a rotation, it would be actually this way around. And so it's not a rotation. It looks to me like it's a reflection, which it is. Now we've got to find out where we put our mirror line. And our mirror line for this would be a horizontal line. So if I just guess and I put it down here, notice that B is only 1 jump away from that, and yet A is 1, 2, 3 jumps away from that. So that's not very good. That's not the halfway point. So we need this to be the halfway between the two shapes, which is going to be here. And the name of that line, well, everywhere along that line, y is equal to -1. So we call it the y equals -1 line. So it's going to be a reflection across line y equals -1. So we've got to first of all work out how many parts there are altogether. So we're told that the ratio of red, yellow and green is 3 to 2 to 4. So to work out how many parts there are altogether, we do 3 plus 2 plus 4, which is 9 parts. So there's 9 equal piles of sweets. Okay, but to work out what one part or one pile of sweets is worth, we're going to get the 99 sweets and divide it by the amount of piles, and that's going to be 11. So one part is worth 11 sweets. We're asked to find out how many yellow sweets, and yellow is the middle one, so it's going to be the 2. So yellow has 2 piles of 11 sweets. 2 times 11 is going to be 22, so it's going to be 22 sweets. So for this question, we need to understand that the units we currently have are in meters per second, and the units we want to get them to or convert them to are kilometers per hour. Now to convert the meters part is quite easy, because all we need to do is divide by 1,000. And when you divide the top of a fraction by 1,000, all you do is you just divide the whole thing by 1,000. So we're just going to divide the whole thing by 1,000. So we've got 95, and we're going to divide the whole thing by 1,000, so we get 0.095, and that's going to be kilometers per second, because we haven't dealt with the seconds yet. So that's the easy part. The more difficult part is converting the seconds to hours. So to convert seconds to hours, we divide by 60 and then divide by 60. So we divide it by 360. Seems simple enough. But the seconds are at the bottom of a fraction, and when you divide the bottom of a fraction by something, you actually times the whole fraction by that thing. So we're going to times the whole fraction by 360. And so we do 0.095 times 360, and you get the answer of 342 kilometers per hour. So our answer is 342 kilometers per hour. To draw a quadratic graph, we want to find as many values as we can. Because it's a curve, with a straight line graph you only need 3 points. With a curve you need as many as you can get. And now we're actually given a table here to fill out. And so I'm going to start off with a 0 here. And here we want to substitute in the x equals 0 into our equation. So we've got y equals x squared plus 11. So it's y equals 0 squared plus 11. 0 squared is just 0, plus 11 is going to be 11. We're going to do the same for 1. So y equals 1 squared plus 11. 1 squared is just 1. 1 plus 11 is 12. Same again for 2. 2 squared plus 11. 2 squared is 4. 4 plus 11 is 15. Now the minuses are a little bit more difficult, but not that much difficult, because when you square a negative, you actually get a positive. So minus 1 squared is just 1. 1 plus 11 is 12. And then minus 2 squared plus 11. Minus 2 squared is 4. 4 plus 11 is just 15. Now you can see here we get a nice little symmetry, and we're going to plot this onto our graph here. So 11 is going to be here, 12 is going to be here, so both of these are 12, and 15 is going to be here. Now when you join them up, what you want to do is avoid having a V. Okay, in the mark scheme specifically it says that the bottom needs to be nice and smooth, and avoid something called feathering where it looks like that. You just want one smooth line. Now the best way I find of doing it is turn the page sideways, which I can't do with mine, but you can turn your page sideways and just one smooth line, and we're going to do a nice smooth bottom there. And I just need to lift, try not to lift with yours, and that should be good enough for full marks. Let's just try it again, just have a bit more of a lift like that. That's also good, and I can do this all day. Like the ones that are bad are the ones with gaps, or the ones where they miss points. So if you had yours like this, where it just missed that point out, or something like that, that would not give you the mark. You just want one nice smooth, just slip there a little bit, nice smooth, and that probably wouldn't, because you can see that I've kind of hesitated there. So it just takes practice, and as I said, if you turn the page sideways, it's a lot easier to draw a C than a U. There are a few different ways of finding out product of prime factors. I prefer using the bubble technique, so we just write the number out and we put a bubble around it, and we split that number into two numbers. So we find two numbers that multiply together to make that number. Now, I always pick the smallest that I can on the left-hand side Now the smallest I can think of is 2, and so 2 times 22 is 44. And now we think about 22, and that's 2 times 11. Now you might be thinking, why have I put the 2's in red? The reason why I've put them in red is they are prime numbers. We can't do another thing for the 2. Well, we can, it would be 2 and 1, but we'd be there all day doing 2's and 1's off the 2's. So we leave it as they are, and 11 actually is a prime number itself. So if I'm going to keep up with the theme, I can have that in red as well. Now, notice it says product of prime factors. So the prime factors are 2, 2 and 11. But the word product means times. So it's 2 times 2 times 11. Notice they're in ascending order. So it's 2 times 2 times 11. Now, if we were asked to do it in index form, we would write it as 2 squared times 11. So we're going to write an expression for the amount of people on the first bus. So they've started with X passengers and they've gone to 11 bus stops with X passengers. So altogether that is 12X. So we're going to have the first bus. And so we've got 12X. And then on the last bus stop, 19 passengers get on. So plus 19. Now for the second bus, well, we start with X and a further 5X come on, because 5 bus stops with X passengers, so that's 6X altogether, and then 79 get on. And it says the first bus finishes with less passengers than the first. So the first bus finishes with less, and the way we show that is with this inequality here. Now all we need to do is solve that inequality. And we've got X on both sides, so we look at the X's. We've got 12X and 6X, so we always take away the smaller amount. So we're going to take away the 6X both sides. And next thing we're going to do is take away the 19 from both sides. And so, meant to be 60. Got ahead of myself. And the last thing we do is divide by 6 both sides. And so we've got X is less than 10. Now, it says here, assuming no passengers got off either bus, what is the largest value for X? Now, it is tempting to write down 10, but it says X has to be less than 10. So the biggest number we can get that is less than 10 is 9. When we estimate, we normally round to one significant figure. So what I'm going to do is just rewrite this question, but rounding everything to one significant figure. But I'm just going to miss out this square root for now. So 3.3 would just be 3, and 4.7 would just be 5. Now, the problem with this 27 is square rooting 27 is difficult, especially without a calculator, and estimating should be done without a calculator. But if I round it to the nearest significant figure, if I round it to one significant figure, that will make it 30. Now 30 is no easier to work out. So square numbers are a bit of an exception. When you've got square root, it's a bit of an exception. You've got to find it to the nearest square number. So 27 to the nearest square number is 25. So square root of 25 is 5. And then 5 take away 3 is 2, times 5 is going to be 10. So our answer is 10. To work out the mass, we will need to find the density and the volume. Density is given to us in the question, but volume isn't. So we need to work out what the volume of this cuboid is. So the volume is just the 33 times the 7 times the 22. So that would be 5,082. And that would be centimetres cubed. And we need to write down the formula for density. So density is the mass divided by the volume. So rearrange this to get mass on its own, because that's the thing we're looking for. So mass equals density times volume. Density is given to us in the question as 2.1 grams per centimetres cubed. Times that by the 5082 for the volume, and we get the answer of 10,672. And then that will give us grams, because our density is in grams, so that is grams, but the answer is asking for kilograms. So to convert that to kilograms, we just divide by 1,000 and we get 10.672. Then we need to round that to 2 decimal places, and so that would be 10.67 kilograms. There are a few different ways you could answer this question. I'm going to do it with a tree diagram, but you didn't need to draw a tree diagram to answer this question. So we've got our first tree, which is our first bus, and the choices are male and female. And we've got our second kind of branch, I suppose, and it's still male and female. And this is our second bus. So the property of male on a first bus is 9/15, and therefore the property of female is 1 minus 9/15, which would be 6/15. Male on the second bus is 7/15, and so female would be 8/15, because they need to add up to 1. And it's independent, so these will be the same. And the question is basically asking what is the probability that both will be female. So to have both female, we need to have gone down this line at the start and then this line again. Okay, so looking at the fractions along the way, it's 6/15 and 8/15. The word "and" in probability means times. So whenever you're finding the probability of getting to an outcome, so this outcome will be FF, because they're both female, you are multiplying the fractions that you go across. So it would be 6/15 times 8/15. So 6 times 8 is 48, and times the bottoms, 15 times 15 is 225. Now you can actually cancel that down. So what you can do is you can divide top and bottom by 4, and that will give you 16. Is it 4? No, you can divide top and bottom by 3, and that would be 16/75. So either 48/225 or 16/75. We're going to start off by just writing the decimal in the standard form, which is 4.3. And we're going to look at the power. Now, if the power is positive, it means the standard form number is a really big number. If it's negative, it means it's a very small number. And here it's negative, so we know it's a small number. Now we're going to do the amount of jumps that it shows in the power. So it says a 5 there, so we're going to do 5 jumps. And because it's a small number, we're going to go to the left to make it a small number. So we're going to go 1, 2, 3, 4, 5 jumps. So the new decimal point is going to be here. All the jumps that we made, we're going to fill in with zeros. And because it's decimal, we're going to start it off with a 0. So our new number is, or our ordinary number is 0.00043. Now it's important to realise that we shouldn't really think about it as jumping the decimal point. We're actually shifting the number, but it's all relative and it's a lot quicker just to move that decimal point. So we can write this as a fraction, so it would be 2.84 times 10 to the power of 11 over 4 times 10 to the power of minus 2. What we can do is split this up into 2 fractions, so 2.84 over 4 times 10 to the power 11 over 10 to the power of 2, or minus 2. Okay, so we're going to start by doing 2.84 divided by 4. So we're going to just do the bus stop method, so 4 on the outside, and we've got 2.84 on the inside. 4s into 2 don't go, so carry the 2 across. 4s into 28 go 7, and 4s into 4 go 1. So it's going to be 0.71 times, and then the rules of indices say that if you divide two powers of the same base, they're both 10, then you just take away the power. So it's 11 take away minus 2. Now the two minuses, the two takeaways, actually convert to a plus, so it would be 11 plus 2, which would be 13, so it would be 10 to the power of 13. Now we've got a bit of a problem here, because standard form must have a number between 1 and 10, and not including 10, at this position here, and this is obviously less than 1, so we need to convert this into standard form. So what we can do is just write the number out again. So I'm going to write this as an actual number, so it's 10 to the power of 13, so it would be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Fill in the zeros. So it would be 7, 1 and all those zeros. And then I'm going to put it back into standard form. Now the decimal point will need to be here to make it 7.1. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 7.1 times 10 to the power of 12. Now, with a bit of practice, you don't need to write out the whole number. You'll be able to just know that if you convert that into 7.1, then you just need to take away 1 from the power. But if you're not sure, and it's not an unreasonable number like 10 to the power of 105, then it's just worth sometimes just writing out the actual number and being 100% sure that you've got it the right way around. So to answer this question, you need to just know the answer off by heart. There is a diagram that can help us actually get there. And if we just draw a right angle triangle and put the lengths as 1, not right angle here, we can use Pythagoras, a squared plus b squared equals c squared, to work out the fact that this is going to be root 2. Because it's an isosceles triangle, this angle here is going to be 45 degrees, and same with the bottom right one, but we're not interested in that. When we label it with our marked angle here, we've got the adjacent is here and the hypotenuse is here. Now we know from trigonometry that cos x equals a over h. The angle is going to be cos 45, and a is going to be 1, and h is going to be root 2. Now, this is a bit of a strange one with 1 over root 2, because we need to actually be able to rationalise the denominator. And basically what that means, if you haven't done surds yet, or you aren't doing surds, is you times tom bomb by root 2. And so we end up with root 2 over 2. So if you ever see 1 over root 2 is absolutely fine as an answer, but if you ever see the answer as root 2 over 2, the two are actually exactly the same. So writing 1 over root 2 is fine, or writing root 2 over 2 is also correct. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.